And this is an advanced talk, maybe you saw already on the schedule. It's advanced because there's a lot of concepts inside. There's many snippets. Don't worry about it if you don't understand anything. The slides will be shared at the end. You have a URL so you can revisit it. I hope you can just go back, relax. If you want to close your eyes and you can, absorb all the things that I will say, it will be fine. I put a timer on me because I like to talk. I already wasted 30 seconds of this talk, and there are lots of things that I want to tell you because I'm very passionate about this topic in general, not only Rust. So my name is Cristián. You can find me there. Send me a message if you need something related to the talk, so let's go for it. So yeah, Python is great. I don't need to convince you. You are here, you travel maybe. This is maybe not your first or your first conference, and you're spending all this time here with people. But I would like to maybe take a step back when you say Python is great. I know surveys are very different. I just wanted to share this that my dear friend Lauren the other day shared that it's the first time that I see in TOB index that a language has such a big percentage increase there. This is for the latest July. As you can see, I have never seen a language with 10% there. So we are still, yeah, well, some clapping. I mean, clapping for Python. It's very impressive that after all the languages we have seen, all the new technologies that we are trying, we still have Python at the top. So I think that we need to really think about how is Python at the moment and how Python can be in the future. So why Python is great? I want to take a step back. As I said, I believe that, this is very cliche, but if you, to look into the future, you need to really look into the past. And I wanted to share that maybe, or ask you something. What is the earliest Python version that you have? Of course, you cannot shout it. So let's say, raise your hand if you try Python 2.7, 2.6, 2.5, 2.4, 2.2, 1. 1.5, perfect, yes. So as you can see, a lot of people is tried many Python. This is nothing to be proud of, I would say. No, I'm really very proud of it, because you have seen how the language have changed, right? And if you're old enough, you understand maybe the change from X to wheels, maybe you use easy install, maybe you know an array. But I wanted to share you a little bit about my story, so then maybe you can relate. So when I started, I was not a genius programmer or anything. I just entered the university. A professor wrote X is equal X plus 1, and I was like, that makes no sense. The X's, no, it's just, okay. So, and then I learned how to code in the university. My first language was C. For some people, it's like, oh, nice. But then, little by little, I started to automate things with Bash. Then a professor told me, like, have you read about Perl? And I started to do some Perl. I don't regret it. I think that I'm good at regex because of that. But then I got my first language flame war. Because back then, I remember it was 2007, a lot of people were pushing because this new language called Ruby was, conquering the world, because it's an amazing thing. They have this new thing, Ruby on Rails. And I was there saying, like, well, but I like Python. So yeah, if anyone is watching right now from 2007 in the university back in Chile, yeah, see the numbers, Python is winning. So, so after that, I moved into some astronomical software development, and I noticed that, oh, Python is also being used here, because before I had a lot of purists, people say, yeah, Python is a toy language, you will never use it professionally. I remember. And there was this software called ALMA Common Software for, coordinating and working with radio astronomy observatories. So literally, you have an interface, you press a button, and a huge antenna will move and point to the universe. And they were using Java, C++, and Python. And I was very proud of it, because, OK, I can use Python here as well. Then I moved into further on in my career, and I was using HPC. And even if in high-frequency trading, which is very different to astrophysical simulations, I was in touch with Fortran, C++, and Python again. So Python was still there, right? So in this context, the most important thing was, of course, you wanted the newest CPU because it was the most powerful things, but everything changed when GPU appeared. Do we have any people that was able to code GPU cards before CUDA? Okay, shaders, maybe you remember it was very painful. Then CUDA appeared, and it was, oh my God, it's so easy. For reference, I checked it out. I was using the toolkit version 4, and I checked there's like 12.9. I was like, oh my God, I'm very old. So it was very amazing to have CUDA. I remember I spent lots of time dealing with the memory, the cache, the register, tried to optimize things. And nowadays, I see Python modules that you have sentences that's 2 device, GPU or something, and it's like, what? Everything works under the hood? So this is really, really interesting for the whole Python ecosystem. So back then, in the context of HPC, I remember, for example, using this cluster was in China. They were very proud because I had a few petaflops, and I was checking top 500, and there was this monstrosity El Capitan cluster with 2.7 exaflops, and I was like, oh my God, the amount of things that we are doing there. And of course, Python will be running there. But yeah, back then I had to remember that when the GPU boom started, everyone said, yeah, I want to put my code into the GPU because now it will be faster. Well, no, I don't want to say any analogy with free-threaded Python, but usually is that when you have more threads, not always everything is faster, so we need to be very careful with that. In that case, some languages were better than others because you would try to squeeze the last performance, align your structures so everything, the register were optimized, copy to different memories, and this was very tricky. So their languages, I said, were better than others. This is a phrase that I don't like, but I understand that for that specific context, this stands true. Yeah, so maybe you have a similar story, and you can relate to this learning process. You might have been exposed to many programming languages while you were studying, learning how to code, and so on and so forth. So for me, the key components here are that the key for success is language interoperability and the evolution of language itself. And this is being reflected in my work as even. This is the only slide about my work, don't worry. And now, for example, we notice with a framework that has been very old, as well as Python, written in C++, we notice that bindings usually are a good thing. They're a lot of work, but are not the key. So even ourselves, we are trying to explore now a way of connecting languages without having bindings, but trying to use different languages' capabilities in order to have this core of a more complex framework or a useful framework. So yeah, there's a new project, but as I said, this is not a talk about that. Programming languages, there. Of course, I will not talk about programming languages. If you go to Wikipedia and you see the list, it's a huge list. I mean, there are too many. We have time to do that. I want to focus on C, because it's the one that I learned. If you don't know the story, in a nutshell, two folks were trying to do a compiler for Fortran. They say, oh, this is too difficult. So they say, what if we don't mix BCPL and maybe small goal? And they created a new language called B. And then one of those guys say, hey, I can maybe improve it a little bit with some assembly optimizations, which is very similar to what all the core developers now, I guess, are doing with all the micro ops and the JIT and everything. Oh, they call it new B, but since people is creative, they say, okay, let's call it C. And that's the story of C in a nutshell. Who recognizes this code? Who knows the language? Just raise your hand if you know it. I was expecting more hands. But since we're talking about language evolution, and later on we have the documentary, this is Python inspiration. Of course, it's ABC programming language. And you can feel the Python in it. I mean, with the 4-line in document, it's a snippet that I always like to show, because I can see the motivations for, maybe, I don't know, maybe I'm super mistaken, that Guido had, like, say, saw this thing, it's like, yeah, maybe you can do it a little bit simpler, try to reduce a few things, make less verbose. And you see that it's very similar. So when I talk about Python, if maybe, I'm thankful, maybe you were in another of my talks, I usually give these examples that I try to make the point, like, which Python? And I have this very old screenshot of my terminals there, and any guesses of which is the Python that you are using? Because there are 6 interpreters there. It's difficult, right? So if you go around, you see that the first is MicroPython, PyPy, Jython, Rust Python. At the end, you have the vanilla Python or C Python that we all use. So as I said, you have many flavors of Python. So when we talk about Python, we need to be very careful, like which implementation. I know we have a standard one, but for some people, Python might be, I don't know, Cinder, if you work at Instagram, for example. I don't know. So yeah, Python was inspired in ABC, and it's written in C, the standard implementation. So why is that good news? Because C is very good with speaking with other languages. And that's, I think, that is the key of Python's success. If you see other projects online, maybe you're familiar, PyTorch, you see there's a large portion there of C++, because Torch is in C++. You have Pydantic Core by the folks that are around in the conference that also rewrote for the new version in Rust. You have a lot of Rust code there. DuckDB, randomly, not that I like these products, but randomly, also they have lots of C++ there, so they're super efficient in that regard. And last but not least, everything of the project from Astral that, like UV, for example, is mostly written in Rust. So the basic approach here is that C extensions are, in my opinion, very simple for you to grasp and try to mix with your languages. Very simple example. This is from the documentation. It's not that I know this code by heart, but if you want to have a Python extension, for example, in C, you just need to declare, let's say, only one function here. You will see a lot of weird things there if you're not familiarized with C, but stay strong. It's only one function that returns a message that says, hello, EuroPython. Then you declare some array of functions. Then you will say, oh, and also I will have a module. And then I will initialize the module. And then you can use the module after you compile it. As I said, this is very simple. But I know you will say, oh, no, C is too complicated. Where are all those stars happening here and there, right? So a little comparison that also I always like to share, like with all the type hints, I hope that I didn't miss any type hint there, and you compare that with a C implementation, I will say that you can understand both languages, right? I mean, even the C implementation. Right? Yes? You're falling asleep. I need to start to get more jokes. So yeah, Python can be difficult as well. Who understands this code? Boy, I'm very disappointed. How do you initialize list if you want to have a list of A, B, C, D, and character, right? Or if, obviously, if you want to detect if n is, come on, you don't know how to detect if a number is a power of 2? Again, okay, an easy one. This. You know it maybe if you like code golfing, no? No other? Okay, well, you can try it out later. I promise it's not dangerous. Or sometimes, you know, you want to maybe calculate Fibonacci and you write Python code. Like, this is valid Python code, by the way. You can copy it and then try to use it later. So why we don't use C, right? Well, there are a few problems, right? Problems in the context of today. Maybe back then, C was an amazing language compared to assembly, of course, but it was very reduced as well. It was very easy for you to understand all the keywords, the functionalities of it. But people started to notice there are issues. In a nutshell, the first one is memory management. So you are very used to do this as a Python programmer, but in C, you cannot do it really easily. And also, you need to free memory when you're allocating memory, so it's also more complicated. We don't have batteries in C, meaning like if I really want to have like a vector of things, I need to implement it myself. There are no object orientation in C, so I need to have a struct and then try to do something to create a vector and then set the elements there. So it's very tricky. You need to reinvent the wheel, no pun intended, all the times compared to Python. The tooling also is something that it hurts. Compiling one single file is very easy, of course, but then you need to start using more things around, like, I don't know, Makefile or Ninja or CMake to generate one of the other two. And this is not so strange to us, I hope, for many people in the room, because maybe many of you are familiarized with the Makefile that we have in CPython, which is very scary. I thought that I knew, like, you know, make, but I entered there once, and it was like, oh, okay, I will not touch this ever. So what are our options? I know for some people they say, okay, no, Swift is for creating iOS applications. But lately, Swift, I mean, at least the people behind Swift, they have been pushing it for being a general purpose language and try to be more active in Windows and Linux. So I know for a fact that at least people is interested in that. It was a really interesting language because it had a lot of inspiration from Python. And in a nutshell, they wanted to have kind of like the Python to C from Swift to Object-C kind of analogy. So the syntax is nice. They have a REPL. They even have optional chaining if you are into Ruby and all those things. And it was option. Maybe we will see the increase of Swift users. I don't know. I mean, I see every year as a conference organizer more and more people with Apple devices. So I don't know, maybe. Erlang, if you are into function, who here is into functional programming or has been good? I expect more hands next year. Erlang also, it's an amazing language. I mean, it's super old as well. They have, well, the only highlight that I want to do is that they have this way of like, you can deploy code and then if something fails, it's fine. The system is like, just keep running. And that's why I guess, in my opinion, because of the virtual machine they have, it is super powerful. So it's a very amazing thing. If you're into functional programming, maybe you saw the little icon on the top left of my screen. So if you recognize it, you get a star. Julia maybe is the thing. I mean, after all, Julia is literally saying like, oh, we want the performance of C, but for people to feel that they are using Python or R or MATLAB. So I don't know. I mean, since Julia popped up, I have seen that like, they increase and increase, more people using it, more packages and everything. So it is something that we might need to see, like, watch out in a good sense. No, it's not a competition. But it could be that they have very good ideas there. I mean, they had a JIT for a long time as well. I have no idea because I couldn't being all the JIT talks that we had. But I don't know if maybe some inspiration was taken from what Julia's JIT. I don't know. But it's really an amazing language. And now I need to talk about C++. And I know a lot of people will get scared and they'll say, oh my God, no, C++. It is something that at least I managed to learn, and it's kind of the main language where I work. So modern C++, what came after 98, it's something that might be very familiar for your beautiful Pythonic eyes. There are many things now that allows you to declare variable without worrying about type. You can make tuples in a very complicated way, but you can make tuples. You have something that resembles Python dictionaries that you can feel familiar with, and even you can do lambda functions if you're into doing apply when using pandas and stuff like that. Moving on, for 13, again, you can do now returns, because, yeah, that's very weird. You had this type for declaring variables, but you couldn't return functions. So you have functions returning. It was very weird. You have templates, if that's the things, binary letters, and digit separators that we also have in Python with the underscore. I hope you knew. C++17, also then you can now unpack when calling functions, which is also very weird that we didn't have it before. Similar with dictionaries, you can do the same now. That's very, I mean, when I see that for loop, it's very Pythonic, at least for me. In 20, there is this thing called, revolutionary thing in C++ called modules. So then you can do import module. And I was like, these have been like, not many other languages. But it took a lot of time. Even the ranges thing, that for everyone here, when maybe you learn Python, you got the typical for loop with ranges examples and everything work quite well. And you understand, well, other languages don't have that. So C++ has many good things and many bad things. C++ is, as a friend said once, is full of shiny features, right? And no, but there are a lot of features. But the problem is that they try to put and fix problems on top of everything else, keeping like being compatible with older versions, and they need to make decisions that sometimes are very weird. We had a discussion outside with I think with some core developers about like the picking keywords is very complicated. For example, in C++, there is like co-await as well for all these async implementations. That is weird. They use co__ for a keyword, but they didn't want to use await alone because other frameworks use it, so it can break code. And well, you know, it's difficult to keep everything moving. But C++, I know that for us it's like, yay, Python, but C++ literally runs the world. I mean, if you start looking outside our beautiful Python bubble, there's lots of C++ everywhere, like you name it. I'm pretty sure that, I don't know, even these screen drivers have a lot of C++ as well. But C++ is very old and convoluted. And it's convoluted because, in my opinion, the process of getting features there is way more complicated than we have now in Python. I am almost certain after all the beautiful keynotes that we had, you're motivated to say, well, maybe I can write a PEP and submit it. Well, in C++ is more work. And there's like, they have a concept of papers, and I don't know. Anyway. So even within the C++ community, there have been a lot of discussion about naming the successor of C++, right? So some people will say, oh, Rust. No, it's not Rust. I mean, at least for the C++, they see Rust as a, okay, that's a cool language for C programmers, but they don't see it as a successor for C++. So one of the options out there, well, maybe if you work at Google, I can't see anyone from the lights, but if you work at Google, maybe you know about Carbon. Carbon is an experimental language that Google is doing. The idea of this, of course, is to be the successor of C++, so they want to have some interoperability with all C++ code, to have some generic system, which is better than the current system that C++ has through templates. There is not even a compiler, so you need to go online, well, download the repo, and there's a weird thing there. And of course, safety is someone that everyone is doing. It's similar to when the folks in data science, they're listening to AI. The people in programming language, they're, oh, safety. It's the same thing. So a few highlights are Carbon. It has a way simpler syntax. They say that it's safer, and it's like a modern C++. Safety again, I see. But it's very experimental. If you're interested, then you can click into that video. It's very informative and easy to follow, so you can maybe watch the full talk there. There is another option that is called, was called Circle, and now they rebranded as New Circle. Let's see, again, New BC. I don't know why they do that. It's also very, it might sound very familiar to you. Well, now they include this, there's a typo there, but anyway. So you can see that it feels maybe more like Rust in a way, but anyway. So they decided, you know what, the problem is not the language, the problem is the compiler, because as you know, C++ is a compiled language. So let's do another compiler that can understand new features on top of the old ones. But well, they claim, well, the only author so far, I think, claimed that it's the evolution of C++, and he wants to fix mistakes with adding new features. I don't know how to go, but at least I believe that it's a better approach than Carbon. So a few highlights I said. They claim that it has fewer defects, friendly features, and savers, and of course, compatible with C++. So again, we go into the topic of compatibility. If you're interested, there is also a very nice talk there, so you can follow it up afterwards. But if we're talking about C Python, we should kind of focus on C alternatives. And I remember a lot of angry people reviewing talks in other conferences when I was mentioning this programming language. I don't know how many people know this language. How many people has written some code in this language? Okay, good. Thank you very much. It's a nice language. I mean, I believe that it's very nice. The syntax can be a bit bad for some people, but believe me, there are many features that I would like to summarize now in maybe a couple of minutes. But as you can see there, they still have the idea of doing the imports. You do have these very long lines in order to do some little prints. So maybe if you were or are a Java developer, you have some flashback right now of the whole things you need to write when you are writing by Java. But it's cool. It's a very simple thing, as you see there. One of the main features that they claim is they don't want to have any hidden control flow. They want to be very explicit with what you are writing there, and also not worrying about memory allocation. They have no macros also, which is for C programmers might be an issue, having a lot of macros around, or the preprocessor itself. They also have compile time and lazy evaluation, which is something very cool. You can have a section of your code. I think there is a snippet after this. You can have a section of your code that will be evaluated, compile, and execute in compile time. And one of the flags that they start to show around is that they want to have testing everywhere, and testing needs to be something embedded in the language itself. I mean, I love PyTest or unit tests and all the testing modules that we have in the Python ecosystem, but having it within the language is quite cool, in my opinion. So, for example, here you have one of the highlights that I believe that are very interesting. Remember that we said before that C was good into talking to other people. You can literally import a header file from C and start using things inside. Of course, this sounds amazing. It doesn't work 100% of the time if you have a very complex header, but it's a very interesting approach, in my opinion. I tried one with Python and I failed completely because I don't know C. But anyway. I told you before about this comtime and testing framework. So you can see here you have this comtime section at the bottom that you can have this. So you have to have some verification where you are compiling, or even this namespace and test. So you can add your test within the same code. For some people, it might be very ugly, but I mean, if you are testing something right away, maybe very beneficial not to need to exit your file, call some testing tool or something, and have it in there. Tools. The tools that the SIG developers have currently are also very cool. I guess that everyone is in love already with tools that can set up initially the project or do many other things. They do have a way of doing the initialization of a project, so you can have the basic structure there with your build script and the main file that you will have. And also, of course, well, you have your files there, and you can have the commands like build run in order to execute the things. Another feature that I think that will be maybe removed, it was very cool, at least for people that maybe is used to cross-compile. Have you ever cross-compiled a C or C++ code? Raise your hand. I feel your pain. I know it's difficult. But if you look at this command line, I hope it's not so small, but it was super easy, literally because they were on top of LLVM. If you don't know that word, later we will talk about it. But it was very easy, just dash target, and you get the executable. I tried this with a couple of Raspberry Pis when I said, no, it cannot be true. And I did this, copy the binary, and it works. So it was very, very cool features. But I think they were planning to remove it anyway. So you can see there, similar thing, as I told you, for Raspberry Pis or other systems. So you have ARC64 or Muscle, you can cross-compile, and it was very, very, very cool. And the last highlight that I want to make for the language is that I told you before, no worry about memory allocation. So they have customs allocators for the code. They said, well, at least they want to be safer than C and also faster than C. But, you know, let's see. Let's see. There is in a really active development. There is a lot of things changing all the time. Maybe you remember, since the title has the word Rust, you remember the early versions when the things were changing all the time. So it's similar story with SIG. And that's a creator, and he has a very, very good talk that I invite you to watch it if you have interest in SIG. If bindings is your thing, if you want to connect now I sold you this the new language and you say, oh, I would like to write all my extensions with SIG, you can do it. They have one a binding generator there called SIG-PyDust, and it's very simple to use. And I think that it's also very important of overall, like why we have so many cool modules in Python, because of some binding generators that are very interesting. I need to drink water. Are we doing okay? Is it too much information? Yes? Prepare, there are still more things to talk. Okay, you mentioned Rust in your title. So let's talk about Rust. Is anyone a Rust developer here in the audience? Are you currently writing Rust code? See, a few hands like. But anyway, let's talk about Rust. So Rust, as most of you might be familiar with, it's a very popular and roughly new language in the 2000s. The selling points, at least that you can find in the website, are performance, which is something that for sure most of you have been seeing in social media, like Rust is faster, oh my God, you know, like start rewriting everything in Rust. It's very reliable, and also it's very good for the productivity. The documentation they have, it's amazing. That I give you that. It's very reliable as well because of this borrowing safety mechanism that they have. It's very cool, so I cannot neglect that. So why we adopted, at least in the Python ecosystem, I believe that it was mostly about, we have PyO3, which is an amazing piece of software. If you don't know it, please go check it out. I believe that the syntax, as the way that they are exposing functions from Rust to Python with procedural macros, it's excellent. I mean, I saw it and was like, oh, why I didn't thought about this before. But it's super nice. It's a super nice thing, and I believe that most of the modules out there for Python that are written in Rust, they are relying on PyO3. Out of curiosity, and this was a real question the other day on the CAPI Summit, does anyone know any extension in Rust that, for Python that is not using PyO3? And they're doing really some weird connections in some makefile or something? No, right? I mean, I'm just curious. I just maybe thought that maybe there would be someone back me, but no. Okay. So I believe that one of the things for success here is that the tools that we have been seeing looking in Rust, maybe many people here is already replacing grep by ripgrep or find by FD and so on and so forth. There is a lot of these GNU tools that are being rewritten, and they're faster, they are, I don't know, they have nice repositories, emojis and everything, so it's really cool to use it. Also, maybe you have been following the discussion that have been happening for a couple of years of having some Rust code in the kernel, the Linux kernel as well. There's always drama, but at least they are trying. They are doing an amazing job there. Many toolchains as well from other languages are also embracing Rust because it's safe, because it's fast, and well, because it's new and it has a lot of momentum. And it's nothing bad about it. I believe that is a very cool thing for languages to have. And as I said, Rust is great. I mean, I am using Rust in a couple of projects, and I enjoy it. I need to confess that, of course, the learning curve was a bit steep for me because it was very strange syntax or concepts that I needed to learn, but I do encourage you to check it out. So then next time when you're in your next Python conference and everyone is talking about Rust, you can jump into the discussion. So there is a but here. And this is a personal thing that I need to do. And by the way, I wear many hats, and the opinions in the following slides are my own. Doesn't represent any of the communities or conference, just be advised. The thing that I was noticing is that everyone on social media was, oh my God, Rust is so fast compared to Python. I mean, who was surprised by this? Do we have any? I will not blame you. Who was surprised that, oh my God, Rust is faster? Yeah, so then I felt bad with my Python t-shirt on, like, oh, why they're saying that? Of course, it's a compiled language. It needs to be faster, right? But there is a lot of people starting into this, and I exposed to many communities with very young people, not so young, people that try to learn how to code, and they even get I don't want to say brainwash, but you know, they get, oh yeah, I need to do Rust, forget Python because that's the future, because it's super fast, whatever, without understanding the concept. So I know there are companies that they need to push for the faster agenda because it's a selling point. It's fair. I mean, we all have to live with, have salaries and stuff. But it's misleading sometimes, and I believe that this can harm the Python ecosystem in a way if people is not very vocal about like sharing the difference of a compiled language and an interpret language like Python and Rust. So I decided to do a real application, super simple thing. Who here knows glove from Python, the module? We have used it, maybe you will say, yeah, no, but Cristián, you need to use path_glove now because it's better. Yeah, but similar idea. So I decided to do a very simple, maybe incorrect, so if you're a PyO3 developer or you know it's and you say, oh, that code is completely wrong, I said, it's the simplest that I could get and the most naive thing that just to mimic the glove function in Rust. So you see there, oh, we have 30 minutes already. It's very simple, so I just have one option that I am passing there in order to know if it's recursive or not. So I hope that everyone here is able to understand. I am explicitly creating a new list with the interface and adding new elements there to the list. Sorry. And then I did some little tests. So I literally create some files with the word hello inside in many directories. So I had 1,000 files, sorry, 1,000 directories, and in each directory I had like 1,000 also files. So in a nutshell, we're like 1 million files in total spread in 1,000 directories. And these were the times for glove, to just list everything, and I'm getting a list of, list everything, I get a list. Display everything, getting the list, and print it. And then I try with path_glove, and it was slower for the non-recursive thing. How many people know why it was slower? Path_glove. Because it returns a generator, and it said there was a list. So I'm really converting a list from the generator, so it's unfair for that. And then I did it in Rust. Surprise. Rust is faster, right? So everyone is happy. I put this thing on PyPI. I get millions of GitHub stars. I will be the keynote next year because of Rust glove, right? But then I wrote it in C++. And then I showed this example in PyCon Lithuania, great conference, by the way, if you want to go. And then after that, some people approached me and they told me like, you maybe are optimizing the C++ implementation. Of course, it will be faster. Well, not really. I went to the C++ implementation. I showed like, I literally wanted to have the same implementation that I did with Rust in a different, of course, different modules and stuff. C++ has something which is called file system. You can do some go recursively to directories and stuff, and you can create a list, return the list, simple. And then they say, that's unfair because PyO3, it's a binding generator, so you have a lot of overhead, right? So you might say, that's very unfair comparison. And then I said, okay, well, let me pick one binding generator for C++ and try the experiment. Back then, I didn't have the numbers, but now I have it here, and I can show you. There is a significant overhead while using binding generators. As you can see there, I got 0.01 more seconds to my thing. Again, someone can say, yeah, but nanobind is super optimized to have like, okay, well, I can try, maybe it will be a very bad binding generator that does things, or maybe I am doing something completely wrong, and I invite you to correct me. Maybe not now, please, but maybe after you can say, yeah, the reason is because you use whatever, and explain to me, and I'm happy to learn about it. I'm not an expert in any of this language, not even Python. I don't even know how to parse a date, but anyway. So if C++ is faster, why we're not using it? Well, I guess you got the feeling already with the previous description of the successor and everything, so it's fine. Memories and thread safety. I think that I wanted to highlight here a few differences for kind of like still sharing for Rust. I think that is in a great language, right? And why people might be like still steering to that. I was showing before some examples, but I want to go back to the code so maybe you can wake up a little bit. So on the left side, you see something written in C. And I have this array. Some people is very confused sometimes with memory safety. What it means is not like there will be some magical thing say like, oh, please, nothing will happen. But you will get explicit errors when some stuff goes boom. So you see on the left side, well, it's a 5-element array. So if you try to iterate with more indexes in C, you can continue forever. And then you see this memory address there. If you know why this invalid element is 0, you can let me know later because I have no idea why it's 0. But it's invalid memory, right? And in Rust, you get this nice message that says, hey, wait. No, you are trying to go over something that doesn't have those so many elements. The tooling of Rust is fantastic. I mean, if you have not used Cargo, please use it. Use it, learn it, copy the idea, and implement it in your favorite framework. I believe that is an amazing thing. That's why I'm very happy, even though I'm not using it for everything that is happening with the Rust extension and the folks from Astral, with UV and the previous RAI as well. It's an amazing idea, and I believe that this is one of the things, in my opinion, that why Rust is so popular, is because they were very opinionated and said, this is how you do things. This is how you start a project. This is how you build it. This is what you run it or deploy it or whatever. But then again, it's easy to create a new language with the learnings of all the other languages, issues. Maybe, I don't know, maybe the Rust developer went to the C forums or the Python forums and said, oh, okay, it's all these pain points, let's put it together, solve them, and have a nice language. Maybe, I don't know, but it's a cool thing. So if it's so good, Rust, why we don't have a full rewrite, right? Before I told you there is a rewrite called Rust Python. They also had an experimental JIT for some time, and it was very cool. I mean, they literally claim, like, well, there are things like Jython or EuroPython that I think they're not very actively developed now. So we want to have something similar with Rust. We can embed this new interpreter in Rust applications, which also may be very useful. In the industry, there's a lot of people that embed, as you might know, like in a C++, for example, application, a Python interpreter to take care of add-ons or plugins or whatever. And also, since Rust, of course, you get WebAssembly for free, so you can compile your code and put it there. I checked the website before this talk, and I noticed that, well, I haven't checked in a long time, that pip also was working. So I was very surprised that, well, I don't know how many packages they can deal with, but at least if it works, it's fine. They also have a very interesting website. I'm sorry you cannot read it properly, but the link is there. You can look at afterwards of all the tests that they have, from what I understood, from CPython inspired, and see what everything is failing so they know where to fix. So I don't know, maybe it's a solution. But if we are rewriting things, why not rethink everything? And here's when I want to talk of our dear Lord LLVM. Who knows LLVM? Good. So everyone is an expert in LLVM, I hope. I am not, of course, I am not. But in a nutshell, just code generator, you can imagine as based on some like layer on top of assembly code, so you can have, you know, easy way of generating code of your favorite language. Is the beating heart of many compilers, for Swift, for Rust, for C++, for I think that I will go over a little bit, but yeah. And the reason that I mentioned LLVM is because, do you remember that before I mentioned Swift? Well, the person that was kind of in charge of writing Swift was the same person that kind of created LLVM. And it's the same person that now is working this new programming language. Maybe you know it already, Mojo, which in a nutshell, it's kind of like a Python flavor front end to LLM backend. So they have kind of some specialization of hardware, because we were talking before, like, you know, GPUs are still relevant. There are huge clusters everywhere, and AI needs more and more computational power. So it's very cool. I mean, I don't want to bore you here with a lot of details, but it's still like I mean, I put intentionally that code on the right side there, that you will say, oh, this is Python, but wait, I'm importing Python. Why they have bar and they have type? Well, that's weird. So you can think about it like it's just like a next level. So it's something, maybe an extension of the Python. Like, I don't want to say the C++ of C, but, you know, a superset of Python in a way. So it's a very interesting, maybe this is one of the things that we need to look for in the future, right? So another option, maybe if you're into the EDCL field, is as Codon. Maybe also you saw Codon at some point. Again, the idea is to have some backend of a Python syntax alike to optimize the calls into the different devices that you have in your system. You know, there are also, I think I have a slide for Triton. Yeah, Triton as well. If you maybe read the OpenAI, they are doing this new thing as well that they have, like, it's still Python, but they focus on a different way of approaching the EPU. So it will be like an equivalent to Numba, maybe. But there are other people looking into this, and there is a reason of why they're looking into Python syntax, because they know, like, we are the #1 in every server, whatever. So people, like, having a completely new syntax or new language might not be the way of going. So, but this is still Python. That's the question that, well, we need to kind of like think about it. So what's our goal here with the Python ecosystem? Making Python faster or move to a new language? So with the upcoming Python features, and I should have removed a few things here because everyone else already is in 3.11, right? I hope. So there have been many changes. And the things that I am noticing here is that it might be, I may be super wrong, so core developers, you can shout, say, wrong, right? It's getting more complicated to bend the limitations of C or the current implementation to do new things while not breaking old things. Okay, so I'm not wrong. And I feel bad because then you're fighting against something that, okay, we cannot do that. It would be so nice if we could rewrite some features, right? This is also complicating a lot the internals. Before, I remember giving talks about CPython, it was very easy for me to explain, oh, then you have the bytecode and everything, everyone is happy. You see that, oh, add, and then binary add, operation add, or multiplication, everything was. But maybe you have been following everything around the JIT. There is a lot of now specialized bytecode, micro operations, and then when you see these micro operations, then there's another step that kind of cleaned these things and wrapped around a lot of smart things happening, which is cool, but at least for me, it was very difficult. I think that I watched like this talk like 3 times in order to say, oh, okay, so it's in this direction. So if you're unfamiliar, or maybe you missed the JIT talks that we had before in the conference, please rewatch them now with all these things in mind and judge them. No, not judge them. Try to learn a few things about the JIT. I think that is an amazing thing. So yeah, is C is good enough to be the base of standard Python? Should we reconsider this option? Because after all, this talk is about the future of things. I don't know. So I think that I will leave you that question up to you. So the 3 options, and just for closing, that I see for the future as a super ignorant person, or maybe not a programmer or compiler expert, at least from my bubble, the story that I show you, the experience that I had, and the languages that I was exposed. Well, the first one is that, of course, the internals keep growing and growing and growing until people get tired of trying not to break things and maybe, I don't know, to make Python better in a way. Again, my own opinions. The whole free-threaded Python, for example, I think it is amazing work. I mean, it's super difficult to do. If you're familiar with the work of people before trying to remove the guild for ages and they were failing and everything, so I think that is very good. But I really feel like, I wanted to put an image here. Do you remember Finding Nemo? When they break out of the aquarium and they are in the plastic bag and they get to the sea and they say, well, now what? Right? And they're like, feel really like bad about it. I, as a C extension maintainer, package maintainer, I feel weird like that. It's like, oh, now what? Because it's very complicated, at least for me, to grasp all the changes that I need to do in my module to completely implement free threading, because it changes everything. So people say, yeah, no guild, everything will be super faster. Well, not always. We saw it before. It could be that it's worse, but anyway. So that's with the first option. The second option is that tomorrow someone announce, I don't know, like another Rust 2 or something, and then people will say, oh, now it's an opportunity to rewrite UV, rewrite another tools in the new language, and people will get more into it, and that's something that could happen as well, but we need to be prepared, at least not to jump into it too early. The third option is that we just surrendered to keep Python syntax. We said, okay, that's it. Let's grab any of those EDCL, like Mojo or whatever, and that's a new thing, and we focus there because it's super specialized internals of the Python language. And of course, the option 4 is that we just rage quit and we go to the field and buy a farm, I don't know, something like that. But yeah, Python is not perfect, and in my opinion, it's very fine. And the more languages we understand, I think that the more we can shape the future of Python. Thank you very much.
Thank you very much, Cristián. Okay, it seems that there is no time for question left, but I believe you have many, many questions in your head, so please post them either to some forum or contact Cristián directly. I think he'll be happy to answer those. Thank you.
Thank you.